So we're just starting with a blank notability doc today, and yesterday I taught you about binomial expansions. Let's just do one. X minus 2 to the third. Now, if you wanted to, you could do x minus 2 times x minus 2 times x minus 2. All right, Jack, could you put your phone in the jail up there? Oh, you don't have one? Okay, my bad. All right, good. So you could do this a lot faster by having 4 blanks like this. And knowing this process. Coop, how do you start? Not to the 4th. You start with x to the 3rd. You would think, but since there's 4 blanks, that there might be an x to the 4th, but the last one doesn't actually have an x in it. I mean, it'll have an x to the 0, but... All right, so then you go x to the 2nd, x to the 1st, and x. All right, then I recommend a different color. All right, Garrett, what do I do next? Okay, -2 to the something. Good, keep going. All right, and then there's one more little piece, which we spent a ton of time on because you could do it by hand or you could do it with the calculator, and that's this little piece where I'm going to zoom in here and put a, notice this was power of 3, right? Who can tell me what goes in here? Say it. 3 and 0. That's called 3 choose 0. And this one will be 3 choose 1. And if you forgot what that means, it means 3 choose 0. And if you forgot what that means, it means 3 factorial over 3 minus the other one, which is 0 factorial, with an extra 0 factorial. And if you forgot, 0 factorial is actually equal to 1. Okay, we learned all this yesterday. And then I know some of you are just like, well, I'll just do it with my calculator. Okay, cool. Do it with your calculator, but I'll save a ton of time because I'm going to go, I have 3 objects and I choose 0 of them. How many ways is there to do that? 1. So that's just a 1. And some people are going to grab that number from Pascal's triangle. You can do that, but I'm de-emphasizing that because you all are going to have to learn this way anyway for the ones that are really large numbers of terms. All right, so totally okay to bust out your calculator at this point. In fact, I think that would be smart. And if you need to borrow one, come on up and borrow one. Just leave me some collateral. And let's finish off this question and get the final answer. And I'm going to put you in a group right now because this is complicated stuff. It's really good to have somebody to compare with. And in a minute, you're going to do a group project involving this meter stick and a rubber bouncy ball. So let me show you who your groups are. Pausing while you do that. So we're back. Let's see how you did. This one was a 1. And then x to the 3rd is x to the 3rd. And that's also a 1 because anything to the 0 power is a 1. So this is just x to the 3rd. Raise your hand if you had that one right. Yay, that was the easy one. What is 3 choose 1? I can do it in my head. I have 3 items. 1, 2. Let's say it's this thing. 3 items. Pick them one at a time. There's 3. That's easy. But there's also a times -2. And that makes -6. X squared. Raise your hand if you had that one right. Okay, good. And then I have 3 choose 2. Well, if you remember, these are actually the same on the chart. Otherwise, you probably used your calculator and you went 3 NCR 2 and you got 3. So this was 3. And then I go 3 times -2 squared. -2 means squaring means the negative will come off. So that'll be 4 times 3 is 12. So this is plus 12x. Raise your hand if you had that one right. Okay, and last but not least, Jack, you get to do the last one. What goes in here? 3 choose 3. Can you do it in your head? Yeah. What is it? 1. Good. There's one way to take 3 things and pick all 3 of them. Okay, good. So that's a 1. And then you times by this. And this should be an x to the 0. I don't have it written, so that's important. Factor that in. So Jack, final answer. -8. Raise your hand if you ended with a -8. Okay, awesome. Do you see that is a binomial expansion? Do you feel like you get that? All right. So remember me saying that I would sometimes give you problems that had like 17 terms, but I wouldn't make it do all of them. So let's do one. Let's say it was 2x minus 1 to the 17th. Would I actually make you do all 17 terms? No, of course not. But I'd like you to think through, what would the first two terms be? Just figure out the first two terms of that. And yes, you may leave your answer with a power in it. So this is the beginning of where this stuff kind of gets hard. And this semester is harder than last semester. And so I want to kind of encourage you to step up. I'm going to show a little video that I can't put on the video here, but of somebody stepping up. All right, so on this first one, did you say that it was 2x to the 17th? Did you remember to put the 2 to the 17th then also? You know what I mean? Like, you can't just say it's x to the 17th. It's 2 to the 17th and x to the 17th. Okay, and then I'm going to use a different color just for effect. So then I'm going to use the -1 to the 0 power. Does that mean the first term is negative or not? When you put something to the 0 power, what do you get? 1. Do you get -1? No, you get 1. All right, so it's 1 times 2 to the 17th, x to the 17th is your first term. Raise your hand if you had that one right. Okay, awesome. Why didn't I even include this 17 choose 0 thing? Because what's it equal to? 1. All right. Then I go to the next one. All of a sudden, 17 choose 1. And what is that, by the way? 17. All right, is in your answer. And then you have a 2x to the 16th. And then you have a -1 to the 1st. So it is going to be negative because of this. And then this is 17. But then we have 2 to the 16th. How am I supposed to write that? Well, I'd put 17 times 2 to the 16th times x to the 16th. How many of you had that one right? Okay, good. That's what we had to do. That's just the first two terms. Could you have kept going? Yeah, and it'd just be more of a pain each step because especially this part, these get to be really big. You'll use the calculator to do them, but... Okay, question.
Could I have just done in parentheses 2x to the 17th power?
On the test, you will have to write it the way I did. Okay. It is true that this, like, could have been written with the 16 as a power on top of it, like up here, but you'll need to split them up like I did. All right, so there's some of the tougher ones. Here's a tougher one from the past. I'm going to give you, and you're going to need a partner for this, I'm going to give you this. The fifth term, write this down, is 405. Part geo, because you have to know it's geometric. If all I told you is that the fifth term is 405, can you figure out everything else? No, I could not ask you to figure out what they're multiplying by. Like, there's no way to tell. If I told you the first term, wouldn't that make it pretty easy? Okay, but, because then you'd know A, and you could use one of our formulas. All right, which formula would you use? Everybody write down the appropriate formula from the board. If this is geometric, that narrows it down to only 2. And I didn't ask you anything about a sum. Just write down the right formula. Well, it's got to be this one. There's only 2 formulas. One's for a sum, and this one's the term finder formula. But, Mr. Server, that's kind of useless because you didn't tell us A. You're right, I didn't tell you A, but you can still write an equation for it. It's just got 2 variables. All right, now I'm going to give you another fact, and you can write another equation, a different equation, for this blue information. The second term See, I'm not nice enough to just tell you the first term. That'd be too easy. And you guys came to this class for a challenge. Second term is 15. Well, then you can do it again. You can write this equation. But it'll have a in it. I don't know what a is. You're right. You still don't know what a is. And you still don't know what r is. But now you have two equations that both have an a and an r in them. So you should be able to solve it. Work together with your partner and figure it out. And once you know what r is and a, then you could answer anything. It'd be easy. Just figure out a and r, and then look at my formulas. They pretty much have n, a, and r, if they're talking about geometric. That's all you really need. Okay, so do your best. This is not easy, but step up. Okay, how many of you guys figured out a and r? All right, well, see the people raising their hands? They're the ones who are probably going to end up with a's on the next test, unless you learn something between now and then. All right, so let's just do the easy part, and let's put in the fifth term is 405, and I'm just going to show you we would have put 405 here, and then a we don't know, and r we don't know, but n was the fifth term, so n minus 1 would be 5 minus 1 is 4. So there's your first equation. 405 equals a r to the fourth. Then we had another one down here, and that's the second term is 15 equals a r to the, I don't know a or r, so I leave them as those letters. N is the second term, so 2 minus 1 is 1. So there's my second equation. 15 equals a r. Now, how do you solve something like this? This is algebra. You guys are in honors pre-calc. Like, you're supposed to be able to do this, like with one arm tied behind your back. Okay? So you solve for a variable like r. Now, is there another way? Sure. If you want to do it another way, besides solving for, like, figure out what a equals or figure out what r equals, okay, I'm going to figure out that r equals, divide both sides by a, 15 over a. Is that the way you did it, or did you guys do it the other way? Or did you do it even a third way? There's a lot of ways to solve this. But I'm going to say r equals 15 over a. Do you mean that means I could, right there, I could put 15 over a right there? So then 405 equals a times 15 over a. And if you think those a's will cancel, you're wrong. Because, look at it closer, do you get that this a here is to the fourth power? And so it won't cancel the other a and just make it disappear. If it did, it would be saying something false, that 15 to the fourth is 405. That's clearly not true. All right, so then you can cancel a bunch of things. In the end, you'll solve it, and you'll get that a equals 5. Raise your hand if you guys got a equals 5. Okay, awesome. All right, if you want to see how I go a little further on this, I go 15 to the fourth and a to the fourth. I get this 4 out of here, and I put both of them to the fourth. Then this a and this a, some of them can cancel. So I now have to do a cube root at the end of the whole, or a fourth root at the end of the whole thing, which is a pain in the neck, but you get a equals 5. And once you know a equals 5, it's so easy. Just make a list, and you go, well, the first term was 5. We just figured that out. And the second term was 15. And then you can figure out your a so easy from that. No, I mean your r, sorry. Your r is so easy now. R had to be 3. You know, because if you know it's 5 and 15, well, duh, you were multiplying by 3. Okay, now you could solve this a lot of different ways. You could have solved for r first and figured out the r was 3. And then you could easily figure out that a would have been 5. So either way, that is an example of a difficult problem. You have to write 2 equations and solve a system. All right. So now here's another difficult problem that I want you to chew on today. And that is a bouncing ball. Do you get if I drop a ball from 1 meter that it will start with a total distance traveled of 1 meter? Would you please put a 1 comma? Now imagine for a moment that it bounces back up, which it would. Let's say it goes up to exactly half of a meter. Would you agree then my next step is to write 0.5 meters? And now what's it going to do? It's going to go back down again. How far is it going to go down? 0.5 meters. And if it's going to continue along the same path, then is it going to bounce up to 0.5 again? No. Where's it going to bounce to next? 0.25. And then it's going to go back down again. Are you getting the idea? Now, is that an infinite series? I dropped a ball. The ball's going to bounce. Bounce, 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 bounce. But this weird thing happens. You would think the ball should bounce infinitely, but it doesn't. Because why? Well, it might even, you could argue that it's still bouncing infinitely little at the very end when you like pick it up. But that takes away this part. If I walk to the door, isn't that an infinite series of getting halfway to the door? And yet I still do finish. I get to the door. And it takes me, let's say it's 20 feet to the door. It ends and it's equal to 20. Even though it's an infinite series, you can add it all up. That's the point of this formula. Would you please finish it? S sub infinity is what over what? Got this memorized yet? Come on, participate. What's the rest of the formula? S sub infinity, A over 1 minus R. Thank you. Okay. Do you get, though, that this is a little weirder than normal? Like, you can't just, like, that's not normal. You can't just say, oh, we're just going to ignore the bounce ups, because I need to know, how far does the ball travel total? If you keep doing it, if you just think about it, you know the ball is going to stop. But if you think about it in terms of the ball bounces and it bounces back down and it goes bounces back up and bounces back down and it does that infinitely, it seems like it'll travel an infinite distance, but of course it doesn't. So how far does the ball travel? All right, so that's what your job is going to be next, is you're going to be in groups and you're going to come up, and actually I'm going to ask you to figure out in a moment, after I show you your groups, I'll tell you how to pick the person. And one person is going to come up and they're going to get a meter stick. And I would strongly recommend using centimeters. So then it starts with 100 centimeters. And then when it bounces back up, do you think it'll bounce up to exactly 50 centimeters? No, of course not. So you'll have to have some way of knowing exactly where did it bounce to. And you'll have to think through things like, should you start, here's my meter stick, here's my ball. Should I start it with the ball in the center, like centered like this in the middle of the ball to be the top of the meter stick, or should I have it on top of the meter stick, or should I have it where the top of the ball, goes to the top of the meter stick? You have to figure out how to make it drop 1 meter to start with, because everybody starts with 1 meter, but then depending on your ball will go down 1 meter and then come back up. Well, that depends on your ball. And you'll have to use the technology in the room, like what you have in front of you, could be used to really zoom in and know exactly how high this ball bounced back up. Pro tip though, don't try to keep looking at second bounce, third bounce, fourth bounce. Just assume that after the first bounce, figure out the R value and assume it's going to keep going like that. You know what I mean? So if yours goes up to 80 centimeters, then you can figure out the R value of that. And then you can just assume it'll just keep doing that same percentage the whole time. You know what I mean? All right. So now you get the outline of what this used to be a lab where you would have to do a full write-up, a couple pages long, worth a whole bunch of points in the summative, and we're just going to make this an experience where you can have more fun with it and just try to think through. And you and your partners have to just come back with your answer tomorrow. Okay. So I'm going to show you your groups and get you a ruler and a ball, and we'll go from there. Okay, so let's make sure, which way did you drop it? If you dropped it like either of these two, then you did it wrong. How should you have dropped it? Does it matter how you drop it? Well, totally, it totally matters how you drop it. Okay, if you didn't drop it with the ball sitting like that at the beginning, then when it traveled, think about it, the bottom of the ball is going to hit the ground, right? All right, so did you drop it right? Raise your hand if your group dropped it correctly. Okay, good. Next thing is you make a list, and I'm going to make an imaginary list. 100 centimeters, 50 centimeters, and then doesn't it travel another 50 centimeters to go back down? Okay, so this one was a down, this was one up, this was a down, You don't have to label it this way, but it's a way to think of it. And then if I actually held true to this, it would be 25 back up, and then 25 back down. And I asked you to find the first 5 terms for your group. Now, do you get the complication here? You can't just go S sub infinity is a over 1 minus r and stick in your numbers and get the answer. It's not going to be that easy. Why? Well, because it travels a lot further than just a normal 100 and then 50 and then 25 and then, because you got these extra numbers in here. So make sure you deal with that. All right, I'm going to have you think that through a little further. Remember, the goal is how far total did that ball travel? Okay, talk to your group. See what you need to do next. So to wrap this up, I told the kids that they had to figure out the total distance the ball had dropped. Went 100 centimeters to start with, and let's say it came back up 50 and then it came back down 50, and it would go up. Then you could predict 25 and go back down 25. So you got this infinite series. So they have a problem like that with the rubber ball in class. And then the other thing is a Schoology quiz, which I had them start in class. So in the end, today is a review of binomial and doing a little real world problem in class. And that Schoology quiz is all you ended up with for homework. That's all I got for today.